Okay, in this video, we're going to go over the 5.1 through 5.3 quiz review. So number one, or actually 1 and 2, it says identify the pairs of congruent corresponding angles and corresponding sides. So number one, we're going to look at the angles first. So let's go ahead and just work through this. Angle A, notice here, has 2 arcs, and angle X has 2 arcs. So we're going to do that first. Then we've got B down here, which has no arcs, and Z over here that has no arcs. So we're going to say B and Z. And then we've got C with 1 arc and Y with 1 arc. Now, what I like to do from this point is go ahead and write a similarity statement that I will use to go ahead and write my congruent statements when it comes to sides. So when I do that, I'm going to say a triangle ABC is similar. And notice I've got them in order here, A, B, C, so I'm going to put X, Y, Z. Triangle X, Y, Z. So then I'm going to use that to write my statements over here. So I'm going to talk about AB, my first 2 letters, notice AB here, and XY there, XY. Then I'm going to talk about my next 2 letters, which are BC, and those would map to YZ. And then my first and last, A and C, to first and last here, Y, X, and Z. That's how we can write our similarity statements after we've written our congruent statements. And remember that angles are congruent in similar images and sides are similar. So over here for number 2, same process. And let's just go ahead and start with H, I, J, K. And I'm going to put them in alphabetical order, H, I, J, and K, and then we'll work through the image. So let's look at H. H has 1 arc here, and Q has 1 arc there. And then I has nothing on it here, and so R has nothing on it over there, R. Now this next one, J, so I went H, I, J. So we went H, I, J, so we went across that little side. So when we do here, we got Q, R going across the little side there, so that's going to be S. So that simply leaves us with P. And once again, I'm going to write my similarity statement. H, I, J, K is similar to Q, R, S, P. Went in the same order, Q, R, S, P. Once again, going to do the first 2 letters, second 2, third, so on and so forth. So I'm going to do H, I, and my first 2 letters of the other one is Q, R. And then I'm going to do the next 2 letters, I, J, and the next 2 letters, which is R, S. Final 2 letters, J, K. Final 2 letters, S, P. And then I'm going to do first and last again, H, K, and first and last over there, which is Q, P. So now we're going to work on number 3. It says a triangle's base is 3.4 inches and its height is 5 inches. A similar triangle could have a height of 2.25 inches. What is its base? So the first thing I want to talk about is how we would set this problem up. So we would do base over height, which means we can keep that throughout the whole problem because those are the 2 pieces we have is base and height. We have the height of the other one and we're looking for the base. So let's go ahead and set this up then. It would be 3.4 over 5. And it says that we have the height of the other one, which is 25, but we don't have the base. So we're looking for the base. So we're going to cross multiply here. 5 times B, and we're going to do, that equals 3.4 times 25. 3.4 times 25 is 85. And we got 5b over here, so we're going to divide both sides by 5, so our b is going to be equal to 17 inches. Okay, so then this other one over here, number 4, says quadrilateral MNOP is similar to QRST. The similarity ratio of MNOP to QRST is 1/6. So I'm going to go ahead and write MNOP here. And I'm going to put QRST because this is the way I'm going to set my problem up. And that's because it says MNOP to QRST. And that ratio is 1/6. Then we're going to start talking about what letters are on top and what letters are on bottom and what we're looking for. So it says that NO, which is on the top, is equal to 6, right? And then we're looking for RS. And notice here that NO are the two middle letters and RS are the two middle letters. So we're going to put RS down here, and that's going to put RS down here over here. We're going to set that equal to 1/6 because that's our ratio. Again, we're going to cross multiply. So that's RS times 1, which is RS. And then we're going to do 6 times 6. And we know that that's 36. Do the same thing with OP. So again, OP is on top. Notice it's up here. So we're going to put our OP over what two letters it matches to, ST there. So that's going to again give us our OP was 3, and our ST is what we're going to end up solving for. We're going to set that equal to our same ratio, 1/6. Going to cross multiply here. So that's going to give us ST because 1 times ST is ST. And 3 times 6 here. So that's going to give us 18 for ST. So number 5 says triangle ABC is similar to PQR. Find PQ and PR. So on this one, again, we're going to put our letters over our letters. We've got AB over PQ. See what we get there. We get 4, and we don't have PQ, so we're going to leave PQ like that. Then we've got BC over QR, getting this from up here, guys. And so that gives us 6 over 12. Well, we know that can reduce to be 1/2. And then our last one that we can compare is AC over PR, and that's going to be 7 over PR. So what we found is an actual ratio here, so we can use that to solve our two that are missing. So we're going to set that equal to this. So we're going to have 4PQ equals 1/2. Going to cross multiply here, so PQ is equal to 4 times 2, which is 8. Then going to do that again with this other one down here, so we're going to have 7 over PR is equal to 1/2. So here again we're going to cross multiply. So we get PR is equal to 7 times 2, which is equal to 14. All right, now number 6. These are two rectangles, and it says that they are similar. And then it asks us to solve for y. So it's really important that we notice here which is the long side and which is the short side. So we can put short side over short side, right? And that should equal long side over long side, okay? So that gives me 1.5 over 6.0, because those are our two short sides. And then we've got 3.3, which is our long side, over our other long side, which is y. So here again, we're going to cross multiply. So this is going to be 1.5y is equal to 6 times 3.3. So 1.5y is equal to 19.8. Going to divide 19.8 by 1.5. So y is going to be equal to 13.2. Number 7 says triangle DEF is similar to triangle JKL, and the ratio of JKL to DEF is 7 over 3. So once again, I'm going to say DEF. Actually, you know what? Check this right here. Notice that. So it says that the ratio of JKL to DEF. So we're going to put JKL on top. JKL over DEF, right? So that's going to equal 7 over 3, right? So then we're going to look where EF is and where KL is. EF is on the bottom. So that's going to be equal to EF over what? KL. And EF, notice the last two letters, and KL, last two letters there. So KL. So we're going to then go 7 over 3 equals, and we have EF. That's 21, but we don't have KL. So once again, we're going to cross multiply here. So this is going to be 3KL is equal to 7 times 21, and that gives us 3KL is equal to 147. Going to divide both sides by 3, so KL is equal to 49. So for 8 and 9, it says apply the dilation to the polygon with the given vertices, state the transform points, and describe the dilation. So the dilation is 3x, 3y, so that means we're going to multiply every point by 3. So that means we're going to multiply every one of these by 3. So when we do E prime, I'm just going to do it up here, that's going to get 3 times negative 4 is negative 12. And 6 times 3 is 18. F prime would be, again, 3 times negative 2 is negative 6. And 3 times 2 is 6. And then G prime would be 12, negative 6 again. And H prime would be 12, 12. Again, all I did there was multiply every point times 3. Then it says what happened. So this was a dilation. I'm going to write it here. Dilation from 0, 0, from center 0, 0, by a scale factor of 3. So we know this was an enlargement, right? Because it got bigger. Okay, so this one over here on the right is, we're going to dilate a line now. So we're going to dilate the line through the points negative 6, 8, and 0, 6, about the point negative 1, 5, and we're going to dilate it by a scale factor of 1/2. So this is our process where we're doing our subtracting, applying, and our adding. So I'm going to start with, I'm going to go ahead and plot our original points, which are negative 6, 8, negative 6, 8, right there. That's our original A. And then we've got 0, 6 right here. So our line would be something like that. I know mine's not perfect, y'all. And we're going to dilate about the point. Let me go ahead and plot this in a different color. Negative 1, 5. So right there, that's the point we're going to dilate from. Okay. So let's go ahead and start working this problem. So we've got our original point here, negative 6, 8. We're going to subtract, I'm going to put S here, our point that we're rotating about. So that's going to be minus 1, 5. So that's going to give us 6 minus 1 would be 6 plus 1. So that's negative 5 there. And then 8 minus 5 is 3. So then we're going to apply our rule. Let me go ahead and erase this arrow right here. It's going to mess with me. Put it inside there. Then we're going to apply our rule, which is basically multiplying everything times 1/2, right? So we're going to multiply by 1/2. So that's going to be negative 2.5 and 1.5. Negative 2.5 and 1.5. And then we're going to add back our point. So this was our apply, right? And then we're going to add. So when we do that, we're going to add back the point that we subtracted. So this time we're going to add the negative 1 and the 5. So when we do that, we get negative 3.5 and 6.5. So then we're going to do this other point over here, which is going to be 0, 6. Same process again. So we are subtracting our negative 1, 5. We're going to get 1, 1. We're going to multiply that by our 1/2. That's going to give us 0.5 comma 0.5, which is 1/2, 1/2. And then we're going to add back to that our negative 1 and our 5. So that's going to give us negative 0.5 comma 5.5. So this was my new A prime, and this was my B prime. So if I plot those points, let's do those in a different color. So that's -3.5, 6.5, which would be about there. Not the best representation, but y'all get my drift. And then -0.5 and 5.5 would be about there. Now, what you should notice is these lines are going to end up being parallel. And if the lines are not parallel, then I didn't plot it right. Okay? This was my answer here for my new points. Okay? So remember your process. Subtract the point that we're dilating from or about, and then dilate it, and then add back that point that you subtracted. So number 10 says determine whether the given polygons are similar or congruent or both. So the first thing it asks us is about JKL to PQR. So JKL is this triangle, and PQR is that triangle. So when I look at these and I start considering, let's talk about how many sides we got, so or how long our base and our height are. So our base is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8, and our height is 2 here. And if we look at this one, it's 1, 2, 3, 4, and this one is 1. So looks to me like we could find our scale factor by comparing our sides. So our ending side is 4, and our beginning side was 8 here. So those are our bases. So that would make me think that it shrunk by a scale factor of 1/2. And again, if you look at the other number, it's 1/2. So those are equal. So that is our scale factor. We could also do that with some points. So we could compare J to P. So if we compare J to P, that's -4, 6. And if we compare it to P, that is -2, 3. And if you notice, if I take 1/2 of everything up here, I get the values that are below, because half of -4 is -2 and half of 6 is 3. And so then what can we say about this? We can say that the images are similar. They're not the same. They're not congruent because they're not the same size. So we could say that they are similar, but they're not congruent. And they're similar because they are dilation by the scale factor from 0, 0 by a scale factor of 1/2. So let me show you that. So now when we talk about this, the images are similar but not congruent, the dilation from 0, 0 by a scale factor of 1/2. The next part we're going to do is figure out the relationship between JKL and STO. So JKL, STO, this one's a little different because we know that the middle one was a dilation, simply a dilation. However, this one looks like it's not only a dilation, but it's also a translation. So we can immediately say that we can count our sides, 1, 2, 3, 4, 5, 6, 7, 8, again, 8 here, 4 here, 2 here, 1 here. So we can definitely say it's a dilation. So we can most certainly say that it's similar because it is a dilation. The other part that we can say now, though, is that if we look at JKL to PQR, it's a dilation by a scale factor of 1/2. Then from PQR to STO, we moved from -2 to -4. So that was a change of that was a change of -2. X would equal -2 here. And then we changed from 3 to 1. So that also is a change of -2. So it's a translation 2 left and 2 down. So the images are similar but not congruent, dilation from 0, 0 by a scale factor of 1/2, and a translation 2 left and 2 down. Then our last one has to do with STO and PQR. So STO is there and PQR is there. The images are congruent and similar. Translations produce congruent images. And again, up here we talked about how we had moved 2 to the right and 2 up if we were going STO to PQR. So we went 2 to the right here. If we look at S to P, 1, 2, and 2, 1, 2 up. If all of these, 1, 2, 1, 2 up, 1, 2, 1, 2 up. So if we do just a translation, then obviously we know that the images are congruent. Other thing that we could say here is because the sides, the base is 4 and the height is 1 for both of these, and that they are both right angles, that we could say that STO is congruent to PQR by side angle side.